Okay, today we're going to be going over problems 1 to 4 from the Algebra 2 Honors Summer Assignment. The first one I want to look at is going to be all the graphing related problems at the beginning. There was some struggles on how to get started on these. So there's a few different ways to approach it. Now it's asking for domain, range, and in behavior. Do not try to state the domain, range, and in behavior unless you know it by memory until you graph it. Right here we have a linear equation. Linear equations are of the form y equals mx plus b, where b is our y-intercept, so our y-intercept is 3, and m is our slope, so our slope is 1/2, a rise of 1 and a run of 2. So you can graph it based upon this information. Otherwise, you can always create a table of values. And have your inputs and your outputs. Okay, pick at least, for a linear equation you need at least 2 points, but having 3 or 4 points would be helpful. I'm going to go ahead and graph it right now based upon our y-intercept and our slope. So if my y-intercept is 3, I need to go to the vertical y-axis, and I'm going to go to 3, and there's my y-intercept. Now my slope is 1/2. That means I need to rise a value of 1 and run a value of 2. Once I've done that, I get to plot my next point. And I can repeat. I can rise 1 and run 1, 2. I could also change my direction. Rather than rising and running forward, I could fall and run back. So I could fall 1 and run back 2. And that's helpful sometimes when you're reaching the edges of your graph. Since this is a linear equation, we want to grab a straight edge, and we're going to use that straight edge to finish off our line. All right. And lines are infinite, so I'm going to put the arrows to show that it goes on infinitely. So my domain, the furthest to the left this graph ever goes is negative infinity. I cannot reach infinity. My inputs were x, less than, the furthest to the right this graph ever goes is positive infinity. The lowest this graph ever reaches is negative infinity. Range is my outputs, my y values. The highest this graph ever reaches, it keeps going, is positive infinity. This domain and range will be true for all linear functions. All linear functions do maintain the same domain and range. Now for in behavior, our framework for in behavior is as x approaches infinity, what does y approach, or f of x approach? And as x approaches negative infinity, what does y approach? X approaching infinity is to the right of my graph. So this represents the right-hand side of my graph. So on the right-hand side of my graph, the further right I go, where is my line going? My line is going up. If it's going up without bound, then y is approaching infinity. If x is approaching negative infinity, that means the left of my graph. So if I look at the left of my graph over here, it's going down. If it's going down without bound, if it's decreasing without bound, we say y is approaching negative infinity. Alright, and that's it for our linear function. Now let's go ahead and take a look at our quadratic. This is a quadratic. Remember, the name for a graph of a quadratic equation is a parabola. You know it's quadratic anytime you have x squared as the highest degree, x squared. Okay? This quadratic is in vertex form. That means this value here is the x value of my vertex, and this here is the y value of my vertex. Okay? The standard form for a quadratic is f of x equals x minus h squared plus k. So notice the standard form is x subtract h. So in this situation, h would actually be positive 1. And then k is straightforward. Whatever sign it has, it keeps. So k is 3. My vertex occurs at h, comma, k. My vertex occurs at h, comma, k. So in this situation, my vertex occurs at 1, comma, 3. So I can go to my quadratic and plot that point. So I go right 1 and up 3. And you could have also used a table of values. With a quadratic, you might have to do more points, though, until you see that turning point. You could also have factored it out, or sorry, not factored, you could have distributed it, used FOIL, and put it in standard form. Standard form tells us the y-intercept, and you could also factor it at that point for the zeros. So there's a lot of ways to approach this problem. Okay, in this form, something I should have added on is you can have an a value in front. Okay, that a value, when it's bigger than 0, we say the graph is concave up. When the graph is less than 0, we say the graph is concave down. This tells us what direction our parabola, our U-shape, is opening in. Okay, so if it's positive, it's going up, so you're going to have a U like this. If it's negative, it's going to go down like this. So in this case, we have negative in front, so its concavity is down. If it's going down, when it's going down, we have a hill. Okay, and so that means we have a maximum value, we have a highest point on the graph. So if it's going down, it actually has a max. And then we need to figure out the max or minimum value. Remember, value, that word value, relates to a y portion. Okay, interval is inputs x, value is output y. And that output of the maximum is always going to relate to your vertex. So we can go back to the y value of our vertex and say that the maximum value is y equals 3. So now at this point, we could just get a general sketch, or we could go ahead and plot another point to figure out the rest of our quadratic. So let's go ahead and plug in 0. So let's find what g of 0 is. So I get negative 0 subtract 1 squared plus 3. Be sure you're following your order of operations. I need to simplify inside my parentheses first. Then I'm going to apply the exponent, so negative 1 squared. Negative 1 squared, that exponent becomes positive 1. Then I can apply this negative on the outside. Now this negative can multiply. So now that becomes negative 1 plus 3 equals 2. So at 0, I go up to 2. Remember, quadratics are symmetrical. So through that vertex, if this is 1 away this way, there's going to be an equal point 1 away that way. Okay, let's get one additional point on this graph, because right now this could look like a V, but we know parabolas need to look U-shaped. So let's go ahead and find what g of negative 1 is. I'm going to go ahead and erase this and find what g of negative 1 is. So same thing, I simplify inside my parentheses first. Then I do my exponent. And negative 4 plus 3 is negative 1. So at negative 1, I go down to negative 1. So now you can see this sharp change. And if this is 2 away over here, then there's 1 2 away over here. And notice the quadratic, the domain, it has an arrow, so it's actually going to keep going to the left forever, so it's going to go negative infinity to infinity. Its range would have gone from down here low, negative infinity, up to 3. So even though this graph doesn't ask us to label that, it's always good to think back to. Now we're going to go on to number 3. So state the parent function in any transformation. Then graph each equation. State the domain, range, and vertex. Well, the parent function of this is the absolute value of x. So my parent function is f of x equals the absolute value of x. And we're going to actually graph this one. We're going to go ahead and graph this one using the transformation. So the absolute value of x. If I think of the table of values for this, let's do -2, -1, 0, 1, 2. The absolute value of -2 is +2. The absolute value of -1 is +1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. So I'm going to go ahead and plot these points. And so notice this is a type of equation that gets us that V shape. Absolute values get us a straight V shape. This is because it's based on a linear function, but the negative portion reflects us. So now I need to state my transformations. A negative in front of a parent function is a reflection over the is a reflection over the x-axis. So we have a reflection over the x-axis. And I'm having a little technical difficulty. Apologies for that. All right. There we go. All right. And +3, notice that is outside the interior of the function. Outside the interior of the function, that is a vertical shift. So vertical shift up 3. So that means I need to reflect this graph over my axis, and then I need to shift it all up 3 points. So I'm going to go ahead and use a highlighter to do my reflection and then do my shift separately. So first I'm going to reflect it. So this one is on the x-axis. This one is 1 above, so now it's 1 below. This is 2 above, so now it's 2 below. 1 above, 1 below. 2 above, now it's 2 below. So there's my first step of my transformation. But that is not my final answer. Okay, that is just the reflection. Now I'm going to shift it up 3. I'm going to go up 1, 2, 3. And I'm going to go to this point, and I'm going to move this point up 1, 2, 3. I'm going to move this point up 1, 2, 3. And that completes the right side of my graph. I'm going to label it G of x. Okay, and then over here I go up 1, 2, 3. I go up 1, 2, 3. And that completes the left side of my graph. So this one here, the V going up is f of x, the parent. And the V going down, that's up at 3, is our G of x. The domain of this function is negative infinity to infinity. The range starts down at negative infinity, so the range is negative infinity. And then it stops at 3, but we do reach 3, so it's included. It is included. And absolute values have a vertex as well. So my vertex, it didn't move left or right, so my x value is 0. And the y value, this highest point, is 3. Alright, one last problem for this video. Write the slope-intercept form of the equation of each line. Slope-intercept form is y equals mx plus b. So first I want to identify my b if I can. So let's see, -1, -2, -3, -4. Down here at -5. So my y-intercept is negative at 5. Slope, I need to take any 2 points on the line and count my rise and run. Or you can do the average rate of change and subtract the outputs over subtracting the inputs. I'm going to go ahead and that's a corner point, and this one is definitely a quarter point. So I'm going to use these 2 corner points. It has to go perfectly through a corner if you're going to count rise and run. So I start from the left point, always start from the left. And I'm going to go down 1, 2, 3, 4, 5, 6, 7. I'm going down 7. Alright. I don't know what's up with this, but that's a -7. Alright, and then it's going to go to the right. 1, 2, 3. So it's going to the right. 3. So my slope is -7 over 3. So now I just fill those in. And I get y equals -7 over 3, x, subtract 5. I'll link the other videos later in the week. Thank you.